Assalamu alaikum everyone. I hope you're doing well. Welcome to another lesson. And today we will talk about VSEPR theory. Uh, VSEPR theory is basically a way of understanding the geometry of molecules. How do molecules exist, what their shapes are, and what are the factors by which their shapes are disturbed or distorted or changed. So that's what VSEPR theory talks about. Now, VSEPR is basically an acronym, and it's acronym for three words. The first one is valence shell. Okay, so we're basically trying to say that only the last shell matters. The inner shells, because they're not involved in bonding, they don't really have much to do with it. Electron pair. So again, we're saying that valence shell, but it's the electron pairs that matter, not individual electrons. Repulsion. And because electron pairs repel each other, this is what the factor is going to be. So we have valence shell, we're only focusing on that. Electron pairs, so we're not taking individual electrons, we're taking them as pairs, because remember, bonding is all about electron pairs being formed. Repulsion, them repelling each other, pushing each other away, making the molecule bigger or wider, and that is what VSEPR is all about. So we're trying to understand that. Now, there are certain ways through which VSEPR is taught, and there are certain ways through which VSEPR is usually explained. But when I was a student, I did not like memorization. In fact, so as I say, I've tried to like mold it in a certain way कि जो मुझे समझने में आसानी होती है. So again, I'll try to explain that to you, and I hope that you also find it slightly easier. But before we do that, we have to understand the 3D formula. 3D formula is basically one way for us to explain or to show on paper how molecules are when it comes to this geometry. So उसके लिए हमारे पास तीन तरह की lines draw करते हैं हम. एक straight line है. Straight line का मतलब है that they're in the same plane. Okay? So this is what it means that they're in the same plane. Same plane का मतलब है कि अगर मैं एक चीज़ को टेबल पे रखता हूँ, दूसरी चीज़ भी टेबल पे रखती है, they दोनों, both of them are in the same plane. That's what it means, that they're both in the same surface and you can connect them using the same surface. Second line that we draw is dotted, and this means behind. Okay? This means the thing is behind that thing. So अगर आप बैठे हुए हैं और आपके सामने आपका लैपटॉप है, so that is going to be shown using a wedge, which means foreground or forward. Okay? And the chair that you're sitting on, the back of that chair is going to be behind you. Okay, so that is how we show. So if you were in the same plane that we are talking about and you have your arm stretched out, that will be in the same plane. So your arm and you are in the same plane. But the laptop or iPad, whatever you're studying on, if it's in front of you, that's going to be shown as a wedge, just like this one. Usually this wedge is colored as well, but आप वैसे भी इसको draw कर सकते हो. And then the chair behind you is obviously behind. Okay, so we show that as a dotted line. So these are the three ways through which we show. So for example, अगर मैं कहता हूँ ना कि एक चीज़ है A and it's connected to something that's B, so I'm basically saying they're in the same plane. They can be connected through the same surface. But अगर मैं at the same time कहता हूँ ना कि ये उसके पीछे है कोई, तो इसका मतलब है this is inside the screen. ये अगर आप इसको देख रहे हो तो ये आपकी screen के पीछे है. And this one means that's outside of the screen. कि ये आपको अगर if you were to imagine, it will be outside of the screen. So that is how we draw the 3D formula. So this is useful in trying to understand how things are, and I will try कि मैं आपको models की एक videos भी बना के दे दूँ जिससे आपको बेहतर अंदाज़ा हो how this thing is going to take into effect. Alright, so that's the idea of VSEPR. So I hope that is pretty straightforward and you understand this. Now, we also need to know how electron pairs work. So electrons exist in pairs, and we're talking about just the last shell. So there are two kinds of pairs there. One pair is what we call bond pair. Bond pair is pair of electrons that are between two atoms. And the other one is lone pair. Lone pair is a pair of electrons that is just with one atom. So for example, in the case of ammonia, ammonia has 3 bonds with hydrogen. So 1, 2, 3. Okay. And then nitrogen has 5 electrons, right? So 2 electrons उसके bond में नहीं थे. So this is lone pair, and this one, which I show as a straight line, this is a bond pair. Okay. So bond pairs and lone pairs, they are the two kinds of pairs that will germinate. Okay. And then the third thing that we need to know is that lone pairs repel by 2.5 degrees more. They repel by 2.5 degrees more. Again, that's a simplified version. Sometimes they don't do 2.5 exact. Sometimes it's more. Again, depending on the atomic size or a couple of other factors. But we don't go into that. We are keeping things simple in A levels. So lone pair repels by 2.5 degrees more. Okay. इसका मतलब है कि अगर आपके पास लोन पेयर होगा तो मॉलिक्यूल्स के जो एटम्स हैं दे विल कम क्लोजर टुगेदर, और अगर आपके पास लोन पेयर नहीं होगा तो दे विल गो फर्दर अवे फ्रॉम ईच अदर. ओके, सो बिकॉज उनकी रिपल्शन नहीं होगी इतनी ज़्यादा. सो दैट्स द सेकेंड थिंग दैट वी नीड टू नो अबाउट. ओके, सो नाउ मूविंग ऑन, हाउ डू वी फिगर आउट द मोलिकुलर ज्योमेट्री. सो सबसे पहले हम क्या देखते हैं कि हमारे पास बॉन्ड पेयर्स कितने हैं, हमारे पास लोन पेयर्स कितने हैं. एंड द सेकेंड कॉन्सेप्ट दैट आई वांट यू टू यूज, एंड अगेन आई मेड दिस कॉन्सेप्ट अप, तो आपको बुक में शायद ये नहीं मिलेगा, बट आई गारंटी यू इट वर्क्स, एंड दैट इज द कॉन्सेप्ट ऑफ CDR. CDR is basically, I'm saying that there is a greater charge there. Okay, so it's a charge dense region. Okay, so charge dense region. So this is a part of the molecule where charges are concentrated. अब 4 तरह के charge dense regions होते हैं, CDRs होते हैं. Single line, that's basically 1 pair of electrons. Double line, that's 2 pairs of electrons. Triple line, that's 3 pairs of electrons. And lone pair, they're all CDRs, and each of them is equal to one another except lone pair repels by 2.5 degrees more. ये दो बातें अगर आपको याद है ना, आपके लिए VSEPR समझना बहुत आसान हो जाएगा. So we have single bond, double bond, triple bond. They're all CDRs. They're all equally good. And then we have lone pair which repels by 2.5 degrees more. Okay. Now moving on. Let's say we'll start with a very simple case कि हमारे पास बेरिलियम डाइफ्लोराइड को ले लेते हैं. Okay, so beryllium difluoride, if I draw it, remember, molecules want to be as wide apart as they can because उससे electrons की repulsion कम होगी, उससे molecule उतना ज़्यादा stable होगा. जब electrons आपस में एक दूसरे के साथ repulsion करते रहेंगे ना, तो उसकी stability effect होती है, वो फिर reaction करेगा, वो electrons will be further away, वो किसी और चीज़ के साथ attack कर जाएंगे, dipoles create हो जाएंगे, बहुत सी चीज़ें हो सकती हैं. So the further they are from each other, lesser repulsion there will be, and they will be more stable, and they will be able to maintain that state whichever they're in. So let's look at this one, beryllium difluoride. Okay, the first thing that you have to do whenever you start this question is put the lone pairs there. So beryllium doesn't have any lone pairs, but fluorine does. So I'll put the 3 lone pairs.